Unit 4 Chemistry, Chapter 10, Part 2, Functional Groups that you do have to name. So, you have in your study a number of functional groups that you need to be able to recognise, say that's the type of functional group, tell us their properties, and for these ones you also have to be able to name the molecules. A functional group means that we've got a group which contains something other than carbon and hydrogen. So if you see an R anywhere, that's our abbreviation for saying just we've got only carbons and hydrogens there. Okay? But then we'll also see other elements there which are bonded, and that's what forms our functional group. And they give a specific set of properties to them. So these are the ones that you're going to have to look at. Haloalkanes first of all. Now, haloalkane means we've added a halogen. So just a single bromine, chlorine, iodine, fluorine in place of one of the hydrogens. Okay? They're all quite electronegative, so they're going to confer polarity on it. They're also all quite reactive, so they're going to make the molecule more reactive than the corresponding alkane. Okay? Here we can see a couple of examples of bromobutane. Okay? One bromobutane where the bromine is on carbon 1, or 2 bromobutene where it's on carbon 2. If we add a chlorine group, then we call it chloro. So these are two types of chloropentane. Okay? Again, this should highlight to you why it's so important to include those numbers. And of course, a molecule can be circular and also have a functional group. So this is cyclopentane, but we've got 1, 2 iodines on it. So it'd be 1, 2 diiodo cyclopentane. Alkanols. Alkanols have got this OH group on them. Okay? That makes them very soluble in water because they can hydrogen bond with water. Because this part is going to become slightly negative, that part will become slightly positive. So it's a very polar group. Here we will see we've got 2 carbons in a row. So this is going to be F, and it's only got single bonds, so it's ethan. But the ending now becomes ol, OL, just like you got there. So this is ethanol. Okay. Now here, the OH group can only be in one place, because if it was over here, we'd still just call it ethanol. Okay, there's no such thing as ethan-2-ol, because that means you're reading it from the wrong side. This one, however, butanol, we could have it here, so that'd be butan-1-ol, or it could be there. Okay, then we call it butan-2-ol. Okay, butan-1-ol is a primary alkanol. Butan-2-ol is a secondary alkanol, meaning that the OH group is off a middle carbon. And you can also have tertiary alcohols, as it's shown down here. A tertiary alcohol where the OH group is off the middle of a branch chain. So basically, this carbon is attached to 3 other carbons, not just 2. And of course, we could have a couple of OH groups. So this is ethanol. There's 1 carbon there and another one there, but it's a diol. Okay? So this would be 1,1-ethanediol. Carboxylic acids, property they confer, you'll never guess it, but they make them acidic. Okay? This hydrogen here is what can be donated. Remember that acids donate a proton? It's just this one, not any of these ones that are bonded directly to carbons. And that's because this oxygen here is so electronegative that it wants to steal all the electrons away. Okay? The full functional group is the carbon, double bonded to the oxygen, and the OH. When we're naming them, we give them a suffix, which is oic acid. So this one here, 1, 2, 3, 4, 5, yes, do include that carbon that's in the functional group. So it's pentanoic acid. Okay? Here, we've got one where we've got a carboxylic acid on both ends. So this would be ethandioic acid. And here we've got a carboxylic acid on a branched one. Okay? So this has got 2 methyl groups. So this would be 2,2-dimethyl propanoic acid. Notice I'm not using a number ever to tell you the position of the carboxylic acid group. Reason for that is quite simple. It can only be on an N carbon. because I can't double bond to an oxygen and single bond to another one somewhere in the middle of the chain. And it's also one of our most important functional groups because it changes the properties hugely. Okay? So for those two reasons, we never give it a number. We just know that we start counting from the end where the carboxylic acid is on. Amines. Amines are basic, so they can do the opposite. They can accept a proton. This NH2 can accept an extra proton to become NH3 positive. It's also a polar group, so it can also form hydrogen bonds with water, okay, with the nitrogen this time being slightly negative and both hydrogens being slightly positive. Okay. We name it with a suffix, which is amine. Okay. So this here is methanamine, this here is ethanamine. If I had something longer than 2 carbons, I'd start putting in a number to say where it was. So I could have 1 propanamine or 2 propanamine. Both of those can exist, so I need the number to say where it can be. Final one that you need to name are the esters. Now, ester has a 2-part name, which is split across this oxygen here. Now we remember it was made from an alkanol and a carboxylic acid. You studied this back in year 11. It's in there somewhere. Okay. So this bit was from the carboxylic acid, specifically a carboxylic acid that was 2 carbons in length. And I know that because it's double bonded to an oxygen. Okay, and I only see that in the carboxylic acid functional group. So it was made from ethanoic acid. This bit here was made from an alcohol, specifically because it's got 1 carbon in length, methanol. So this bit's going to come first. This is going to be my methyl. And here is ethanoate. Another example, I'm going to search for my oxygen, that's where I'm splitting it, and I'm look first at the side that doesn't have the C double bond O on it. So I found that side, and it's 2 carbons in length, so it's ethyl. It's just like naming a branch. So this is ethyl. Then I look back at my other bit, 1, 2, 3, 4 carbons, so butan O8. So this full name is ethyl butanoate. Next video we'll look at some more functional groups, but the good news for those ones, you don't need to name them.